Let's look at an example of a transformation of a cosecant function, and we'll know that secant functions are going to work really similar to this. So I have 2 times cosecant of pi x, and we're going to need to find out some stuff about this. First of all, I want to know the period. Well, the period is the period of just the generic original function. The period of the cosecant function is 2 pi. And I'm going to divide by the coefficient of the x. Well, that would be pi. 2 pi divided by pi is 2. I kind of feel naked without the pi there, but that's what it is. The period is 2, has a length of 2. Well, I'm going to start from there. Let's get a graph going here. I don't have a phase shift. I'm not moving left or right, so I know that the y-axis is an asymptote. Cosecant of 0 is undefined, so I'm going to have an asymptote on the y-axis. And we also know from looking at the generic graph of a cosecant function that it takes 2 asymptotes to make one complete period, and we'll have an upward-facing part and a downward-facing part. So from 0 to the end of the second asymptote is 1 complete period. That means this is 2. Well, the other asymptote is halfway in between. Halfway in between 0 and 2 is 1. And there's going to be important points in the middle of each of those, halfway between 0 and 1, halfway between 1 and 2. It does feel weird without the pi, but it doesn't belong there because it divided out. So, all right, we got some framework set up here. Vertical stretch by a factor of 2. What that's going to do is it's going to make the minimum be at 2 rather than where it usually is at 1. So I'm going to have an upward facing piece between my first 2 asymptotes. If I had a negative here, I'd get a reflection and the downward facing piece would go first, but I don't, so it doesn't. And instead of the maximum being at -1, this stretch is going to stretch it down to 2, and I have my downward facing part here. And there's the graph. That's actually done. We have the asymptotes labeled, have both pieces of graph in there, but there's other stuff to do. The domain, I can use anything for x except where the asymptotes are. So all real numbers except the asymptotes. Well, the asymptotes, there's one at 0, there's one at 1, there's one at 2, the next one's at 3, the previous one's at -1. So we're going to say x equals n, where n is an integer. The range, y values, our no-fly zone here is between -2 and 2. So y values as low as you want to go till we get to -2. And then starting up again at 2. And as high as you want to go. There's the range. Asymptotes, vertical asymptotes, have an equation. They're vertical lines. So the equation of a vertical line is x equals any integer. And we have labeled maximum and minimum points. I said that backwards, maximum and minimum points. Points in the middle. Yep, we're all good. We're all labeled. And there's our graph of a cosecant function.